Hi, Stephen.
Hey, how's it going with you?
Oh, yeah,
Oh, that good, eh?
just come out of a meeting about uh, two-phase, like multi-phase modeling and R&D plans for that, which is a bit of a head melter. But
Nice.
yeah, how about you? How you doing?
Yeah, not bad. Doing a bit of bug splashing on we're releasing like a new product, like a dashboard type thing that's
Um,
gonna build into a
I've
digital twin eventually. Um, so I'm basically leading that almost single-handedly. I'm just squashing a bunch of web dev bugs. I hate web
nice.
dev. I'm not meant for it. Not meant
The
for it at all. But yeah.
equivalent of your least favorite discipline in a triathlon, I guess.
Yeah, yeah.
So I mean, so full disclosure, um, I've not given the, excuse me, I've not given the white paper the attention that I should have done. Um,
Okay.
the the honest fact of the situation. Um, I think better to just say that than to. Uh,
Yeah. To be honest, I haven't looked at it since last week. I can't remember if I said I would do anything last week, um, on it, or 2 weeks ago. Uh,
no, my commitment, which like I said, I haven't. I'm looking at the printout that I printed out. Do you remember I said I'd cut out all of the stuff in the use cases
oh
um,
yeah.
to try and like work that out. And I've got the printout that's been on my desk winking at me um, since our last meeting. Um, oh, hi, James.
Hi there, strangers.
Hi James.
Nice to meet you.
Yeah, it's nice to meet you guys. I'm new to OCP, so can't really contribute a lot. I can share my background if when the group gets a little bit bigger this morning.
Yeah, that'd
Hi
be
there.
good. Have a look at your opportunity things.
I mean, this is already the biggest group I think we've had in recent times. Hi, Paresh.
Hey, morning.
Yeah. Hey Gersh.
Sorry
I
I missed the last 2 weeks.
I left you guys. I left the liquid cooling meeting for this, so I'm looking forward to it.
Hey, good morning, guys. Do you know who's supposed to be who's supposed to be running this one?
So I guess that would be between me and Stephen.
Okay,
Um,
so we're just waiting a few minutes.
uh, oh, Sam's joined as well. Busy today.
I just wanted to make sure whoever is gonna lead is actually on the call and we're just not waiting for them.
Oh
No,
no.
no, no, we're here.
Perfect.
We have quite a variable number of people attend, so
Okay.
um, sometimes people come in like 5 minutes late.
Yeah, no worries. And my name is Eva Klimek. I'm out in Chicago. I recently transitioned over. I work for OCP now. So I'm just kind of on different types of calls to get myself a little bit more immersed in some of the topics I'm not familiar with. So I'm just here as a fly on the wall. But if you guys need anything OCP related, I can also take that back to my group, if that makes sense.
Yeah.
Okay, awesome.
All right. Pleasure to meet you guys.
And you. So I guess maybe we should do a round of introductions, given we've got a couple of new people. So my name's Matthew Kaufler. I'm a product engineer with Cadence, a software company, and I work on specifically the Reality DC software platform, which is a sort of data center digital twin with a focus on simulation. So grew out of essentially a CFD, originally CFD modeling approach to data center sort of thermal design analysis, and then have extended out into sort of operational considerations around flow network modeling while we do that for design as well, but then also some power network modeling and data network connectivity. So we've got sort of relatively broad covering.
Where are you located?
In London, yeah,
In
London,
London.
England.
Okay, what is the company?
The company's called Cadence Design Systems.
Okay.
Who'd like to go next?
Guess I'll go next. I'm Stephen Clement. I'm a kind of an engineer / researcher for a company called Interact. We specialize in hardware modeling and kind of advising data centers on hardware upgrades that can meet their sustainability goals, essentially. My background is mostly academic. Worked in a number of universities and then joined the data center industry about 7 years ago. Worked in a number of companies and mostly I've been funded by a UK government research grant looking at data center digital twins.
Yeah, and my name is Kurosh Namati. I'm with NVIDIA. I am a data center infrastructure engineer. I lead the team of data center digital twin, and we basically develop digital twin for internal use and or for partners. And a concept that we call it as a digital twin blueprint that basically we can make it available for all different type of partners from OEM to ISVs to data center owners to use digital twin that basically they can do deployment of AI factories that will kind of expedite the deployment, and then it helps with the operational part of the data center to make it kind of more reliable and sustainable.
Hi, my name's James Fry. I work for 2050 Partners of the California investor-owned utilities. Help me, they pay my way to come to meetings like this. I'm currently part of ASHRAE and IEEE on other efficiency programs. The data center is a highly intensive end use that I'm paying attention to related to analytics and specifically around metering and understanding how metering can be the ultimate data source for performance. Funny enough, but I used to work at Schneider, adjacent to the CFD people, and I used to work at Cadence as well. So lucky break.
Yeah, so my name is Sam Lai. I actually work for Lion, the company actually kind of an electronic manufacturer in Taiwan. So we are actually one a bigger supplier for actually power shell and also kind of PSU and BBU to a couple of the hyperscalers. So right now, I think we're looking at also digital twins to both simulate the power and the space, because the scale is so big. I think it's a digital team make more sense to look at all those simulation before when we actually deploy a lot of like those servers and power rack. That's why I kind of like try to listen to this group and what's happening on this side. So.
Well, nice to meet everyone.
Yeah.
I guess so the thing that we've been mostly working on in this working group for a little while now is a white paper. So we're essentially trying to release an initial white paper for the working group on what is a digital twin for the data center, and then kind of discuss some of the issues that arise from that, some of the challenges in adopting digital twins, and what are and some of the opportunities in adopting digital twins for the sector. Yeah, so I guess we could show what we've got so far on that. Unless Matthew, do you want to say anything else?
No. I think that'd be useful. And I was actually thinking that that Sam and James might particularly in the use cases section be able to contribute some thoughts from their sectors that perhaps we've missed in previous conversations. One of our I guess as a group, one of our limitations we've mentioned before, right, that we often have relatively small numbers of attendees, so it's often Karusha's a repeat attendee, and then there's a gentleman from Dassault Systems who you might have heard of, who also quite frequently attends, but it means that we've got a relatively limited perspective on use cases for data centers or digital twins beyond our own practices, if you see what I mean. So it'd be really useful to hear from Sam and James particularly on any sort of gaps in our coverage in the framework for the white paper at the moment. I think so. Yeah, I think it'd be useful to have a look at what we've got so far.
Yeah. Okay. Does
I
everyone
think we
have
start
access?
soon.
Does everyone have access to the white paper or not? Matthew, you struggled. Are you able to access it now?
Well, look, yeah. Context for that, people, is that I have intermittent access because of Infotech changing their policies at Cadence.
No, I have access in the shared drive.
Yeah, that's okay.
Yeah, and I do too at the moment. Good. You want me to bring it up on screen, Steve?
I can do it. I'm just hopefully you can see that.
Yeah. Let's come up.
It's just if anyone wants to, well, first of all, please contribute to the white paper if you can, and if anyone wants to kind of jump around and look at other parts of it or read ahead, then they can if they're able to access it. Yeah, so it changed a bit since the last time you saw it. We kind of reorganized some of it, addressing some of the comments we got from Mark Dancy and Cliff. So Sherman has contributed an introduction. It's pretty good, I think. Essentially, it covers broader question of what the white paper is trying to do, and how we're looking at kind of the transformative potential of data centers, digital twins and data centers. Then we've broken it down into first kind of what is a digital twin. I should say when we've talked about the white paper, we're thinking about 3 potential kind of readers in the audience of this. One would be your data center operator that maybe, or data center designer or builder or whatever, who has heard about digital twins but isn't really sure what they are. So kind of a novice in that respect. The second reader would be someone who is using digital twins in their operation in their day-to-day, and maybe is looking for kind of what else can I do in that space. And the third kind of section of the audience we're trying to hit is the engineers working on the digital twins themselves, so the people building the tools, and kind of bringing together those people. A lot of us here are that kind of side of thing anyway. And kind of highlighting what are some of the challenges in putting these tools into practice and bringing them together, and how can we as OCP together help with that. So some of this might be a bit rudimentary, but that's the reason why, is because we're trying to address those three segments of the audience. So essentially we start with what is digital twin. We have to start somewhere. So I'm trying to come up with a definition of a digital twin. I think we're basically there in agreement with this. It covers largely what everyone in the call so far has agreed with. So it's digital twins with virtual representation of a physical system or object, either existing in the real world or intended for future creation. And the virtual representation is dynamically synchronized with its physical counterpart through continuous data exchange. That may be a little bit dense, but that kind of covers every aspect that we've talked about in regard to digital twin so far on the call. Then we've kind of worked out some places where digital twins in data centers help, and what kind of problems they try to address. So we need some kind of infographic for this. But yeah, essentially it's a question of what are the specific nuances around digital twins for data centers. Come up with a couple of points there that kind of differentiate them from other industries. Data center digital twins obviously quite interesting because they cover multiple different subsystems what the data center is consisting of, and therefore they touch on a number of different disciplines. And yeah, here are some of the challenges. I don't know if anyone has any other challenges to add to that, or any other problems that they can address, but I think this largely covers all of our experience within this core group. Then the white paper then breaks out into kind of what are the use cases of digital twins within the life cycle of the data center. We've chosen to do it by the life cycle because previously when we'd broken this out and kind of looked at use cases, we'd mostly focused on kind of the operational context. And then we were informed by our friend from Dasso that there's a lot more in the digital twin space before you get to the operational context. So we're trying to capture that here. So there's a number of different use cases that we've identified, and then we've identified some kind of the issues around the use cases, and also kind of what the simulation needs to be, or kind of what some details about the use case. The intention for this section on section 2 is that we can give in each of these use case sections, we've got a design and build phase, we've got an operation phase, and there we're covering everything from construction, virtual commissioning, and carbon footprinting to asset management, capacity planning, predictive maintenance, energy efficiency, that kind of thing. The aim for this section is to give a broad overview of kind of these use cases and kind of the tooling that might be involved in these use cases, the data that's required, that kind of thing. but also have breakout sections for real use cases. So real applications of this where one of us may have used the digital twin and give kind of a case study. Only about half a page for a case study, but very briefly kind of what was the problem, what was the digital twin that was involved, how did we solve the problem, what's the benefits, that kind of thing. I think I've identified one from an Interact that we could potentially use. I think you mentioned you might have one, Matthew. Or did that need to go through clearance first?
I mean, I'd need to get definite clearance, but I mean, we've got quite a few case studies out in the public domain already. So in that sense, I think a lot of those could be sort of reworked without too much of a permissions problem. It's the ones that aren't already in the public domain that would be more of a challenge, I think. But yeah, I need to. I'll make a follow up on that. Actually, that's something I need to get definite clarification on.
Okay. So yeah, if any of you guys have any concrete case studies that you'd like to contribute to this section, they would be most welcome. Karush, I think we mentioned this I think it's last meeting. Network modeling came up in the context of NVIDIA. I don't know if you've got any more information on that. I think it just came to the conversation. We added it in as a use case potentially in the operational phase, but none of us have had any experience with that. So
yeah, so basically at NVIDIA we have something that we call as NVIDIA Air, and that is the modeling of the network side. Based on the information that I have, that is the connection between the racks and to the network, all the basically how the GPUs are connected to each other. We have a model of that basically can replicate the network side. But I need to kind of work with our NVIDIA Air team to get more information that I can put it here in the white paper.
okay, that'd be an interesting addition.
It looks like power, cooling is represented. Is power represented?
Yes. Cooling and power system sizing is represented. What do you mean in terms of power?
Well, the idea is how is power distribution designed? Where are the points where efficiency is lost because you need some sort of functionality, and you kind of understand that that whole stack of efficiency from source to the load being converted to valuable IT work, you know?
Yeah.
So less about the sizing and more about reducing the distribution losses and that kind of side of things.
Right, at least being aware of them and understanding the value you're getting for that.
Mm.
I always think about it as energy productivity when I can. It seems it's more of a positive oriented discussion instead of a negative. Because in the end, we're an IT work factory, right?
Okay. Yeah, that is good. That's like a good use case we hadn't added.
Early on in the document, when you talk about the word twin versus other definitions, you take care to position the word twin against other types of digital models and model-based behavior.
Yeah, we've had a number of discussions around that of what is a digital twin versus what is just a simulation or a model. In our, I think in our definition, essentially it comes down to the interaction with the real system and the model. So there needs to be some two-way communication there.
That's cool. Yeah, the idea is it's a comparison of some sort, not just a singular model on its own, but something else. I was thinking you could also twin one rack against another if you don't have a model. Things like that could be brought up in conversation as well.
Yeah. Yeah.
Yeah,
I don't
actually,
know.
I think that's a good point. So basically, we have to differentiate between CFD analysis and digital twin, because basically what we discussed earlier, CFD is a big part of the digital twin, but CFD model is not a digital twin. So a couple of elements that is being added to this is one of them is kind of having CAD model that is a good representation of the geometry, and basically the metadata that can be added to that kind of library item, that it has all the CAD and it has all the metadata from the OEMs, which be, in my mind, it should be kind of in the modular kind of fashion that you bring different parts like, I don't know, CDUs, racks, and these kind of items. You can place them in the as a CAD file, but it has all the metadata embedded in it. It has all the control system that behaves as the physical twin. So that is kind of making it, in my mind, as a digital twin. And that's a differentiation between the digital twin and any kind of CFD or flow network analysis.
Yeah, I definitely agree. Extensions into the control system side of things is pretty vital for the behavioral element. Like a static CFD model isn't really anything more than a snapshot in time. So you do definitely need this sort of control characterization. I think the detailed CAD is a lot of this depends on the application case, right? I think you can get some digital twins that have no geometry representation at all. But yeah, then that comes to, well, we'll come to the complexity infographic, I guess, a little further down.
Yeah.
Actually, about the, sorry, but actually about the CAD, we kind of internally talk about this a lot, and the amount of detail that is necessary to be added is kind of different. So let's say as a CDU, we don't want to model all the kind of nuts and bolts inside the CDU object. In some cases, having like a shell is kind of enough, because it has inputs and outputs. So you get the inputs from the return side of both primary and secondary, and then the supply side is going to be something that our digital twin model should bring. So in some cases, it doesn't matter if you model all the kind of coils and pumps and everything together, because the main important part is the capacity, pumping curve, and the control system, as you said. So I believe that different item, it can have different layers of CAD, and that different layers of CAD embed different amount of detail. That's kind of usable for a digital twin. Yeah, so it's the
No, yeah, I think that I think you're right. I think the I mean, we'll probably get into that later, but the definition of the interfaces between many submodels is a key problem that needs to be addressed in digital twins in general, but especially in the data center industry with all of the different tools we're using. No, the other thing I was going to add was that another thing that kind of differentiates the digital twin from a simulation that we talked about is kind of the use case that the thing that you're using it for. So a digital twin is kind of giving you what if analysis in a more reflective way than just a bare simulation. That all needs to be brought into the introduction. Yeah, so essentially this part covers as many use cases as we've been able to identify. There is quite a challenge as we've come up with all these use cases. There's definitely a challenge in how to organize all of this information in a way that is digestible. We're not entirely sure on that yet. It might end up being condensed into a table of some kind. It might end up being broken down further into broader sections. We're not sure on that, and I think Matthew and I kicked around a couple ideas at the end of the last meeting, and we didn't come up with anything that was particularly groundbreaking there. And then so finalizing on this kind of what are the use cases in digital twins in the data center. We've kind of got an overall just summarization of what does it give you. So we're hoping that by having all of these various use cases, the reader essentially sees their own use case reflected in this and say, oh yeah, that I either already use a digital twin for this, or that is a problem I'm dealing with in my data center. I need to go find a digital twin to do that. And broadly speaking, we've identified that largely they're all about risk mitigation, improvements in process, enhancing decision making, and resource optimization. And I think this is one that we've talked about a lot, especially within the context of data centers, is that we're essentially trying to improve an ROI or total cost of ownership, because data centers aren't run for free. And then, so then we get to, I think, where Rishi's talking about, we've got the technical challenges then. So we've identified a number of challenges and barriers that can exist if an organization were to want to adopt a digital twin of any kind. Some of these are, or quite a lot of these are actually more around the technical side of bringing that digital twin vision of being able to put all your simulations together, have your models from different vendors come plug in and all just play together nicely. So yeah, we've identified a number of problems around ontologies and definitions. SimReady is an NVIDIA term that Krusha shared with us previously to kind of encapsulate some of this. there's issues around code simulation, issues around model interchange and data interchange, the details in the models that we just talked about, validation, and particularly there's a number of standards that can help help in some of these challenges, whether they are 100% suitable for the use cases that we're talking about is up for debate. But at least there are standards out there that exist that can kind of speak to some of these challenges. And the question is how we adapt them or adopt them for our use case. So this section, if there's any other challenges anyone's aware of, that would be great. We kind of came up with the idea of potentially doing some kind of gap analysis on the current state of digital twins. That kind of guides the next steps for this working group as a whole. So this is hopefully more aimed at tool vendors and people working on tools. But essentially it's also designed to help us as the digital twin working group to identify, okay, what do we do after this? I think we're ending up leaning towards some kind of definition system that around how different simulations can talk to each other. But that's not settled yet. Then after we talk about all the challenges, the question then is how do we adopt the digital twin? So how do we go into using digital twins if you're not already? And here we've done a bit more work on this. So can talk about different types of digital twins, how you might go about getting them into your organization. One of the things we've talked about is potentially offering a kind of measure of maturity for a digital twin. We talked about previously when some people talk about digital twins, they're talking about fully fledged CFD models, modeling the whole system or multiple systems in close simulation. And other people might just be talking about a spreadsheet for a CAD model. And there needs to be some consistency within the industry as to when someone says, I'm talking about a digital twin. Oh, sorry, Matt. James, you raised your hand. James,
Oh, yeah, thank you.
Yeah, sorry.
I'm not as adept in the vocabulary set you all are using. When you talk about co-simulation, are you discussing simulating individual subsystems and then establishing how the subsystems interact with each other, like power and compute and cooling, all those different subsystems? Is that what you mean?
Yes. When I say co-simulation, it's generally referring to having two separate simulation engines that are algorithms running, and they're interacting at certain points and conveying data between them. That generally then is on a subsystem basis. Matthew, do you want to add anything to that?
No, that's, I mean, pretty much on point. But yeah, I mean, it's as an example, from sort of my wheelhouse, if you see what I mean, co-simulating a flow network model with a 3D domain where you might be simulating the chilled water distribution system in a transient situation, whilst also simulating what's going on in the air side of a data center. You know, you could pretty well have power system co-simulation as well. I know we've had conversations with people about sort of battery discharges and recharges in transient situations where you'd maybe be looking at simulating what's actually going on sort of from a thermal and power perspective within the batteries, and then that would be co-simulated with a more general CFD model of the power room, for example. That's kind of co-simulation we're talking about. So like Steve said, just two or more simulation engines exchanging information, as opposed to having to have fixed boundary conditions in one or other of those simulation tools.
Thank you.
Mm.
Does the discussion also include hardware in the loop or a model in the loop where it's a mixed mode between reality and model?
I don't think we've discussed hardware in the loop at all, but I know that is an important aspect. I don't know, I wasn't aware until last week that it was used extensively in the data center industry. I know one cooling company that's now looking at hardware in the loop models. But we haven't included that, and that's probably something that we should include. I don't know if do you have any experience in that, James, that you can speak to?
I just remember when I worked at Schneider, we had the UPS modeled into the CFD system for cooling and stuff. But that's a couple jobs ago, so I can't be helpful other than bring it up in general. Thank you.
Okay, thanks. No, that's a good that's a good addition, actually. Yeah, so essentially one of the things that we've looked at is more in the operational context than in the full life cycle, and this was something that was pointed out, which is why this isn't kind of fully finished and fleshed out yet. Talked about digital twin maturity, so kind of came up with this 5-level, 6-level system, where essentially on the bottom at level 0 you're not using a digital twin, and then as you're increasing, you may be collecting data and using basic modeling for it, then moving on to kind of physical simulations, and then eventually kind of augmenting your operations with autonomous systems that are either proactively making changes or proactively alerting you and are integrated in with the control systems. This is, as I said, as we pointed out, that it's very operational, the operational side of the life cycle, rather than the design and build side. So we have thought about how we can incorporate the design and build into this, or whether this is even applicable for design and build. We're not sure, but yeah, again, input was always welcome on this. And yeah, finally then is just conclusions. So an overview of the benefits, any identification of best practices, so we can start providing some kind of actionable insight from the working group to the rest of the OCP community. And we think that the conclusion should also include kind of, well, what are we doing next? So that's probably something around interoperability, standardization, and maybe alignment with the OCP ready data center specs. Yeah, and so that kind of covers what the white paper is, where we've kind of got to so far. Yeah, any feedback or anything on that would be good. Or if we've obviously missed anything out, or if you think there's a section that needs to exist that doesn't currently exist, or needs a different kind of focus on it. Yeah, be interested to hear if anyone's comments on that. Okay, cool.
Okay. So when actually is the you guys plan to kind of publish this white paper or submit to OCP, right?
Originally we were going to rush to submit it for the European summit,
Mhm.
but that didn't happen. So we've kind of been told to submit it when it's ready. I think we're aiming for the global summit, which is in October.
That's what I was gonna ask for. If you guys are, I don't know if you saw, but we're opening up the abstract submissions this week. So actually, I think today or tomorrow. So if you do know you would be able to travel to the global summit and you would like to have a talk around this digital twin. I don't know if you talked to Mark about that or, but the open for abstract is available for 2 weeks. So you want to make sure whoever wants to take lead on it, if you want to send me, I'd be happy to look over it for the submissions. It's just the abstract. It does not need to have anything, any slides or anything like that. That would come later once it's if it's accepted. But if you do want to have a talk, just keep that in mind. In the next 2 weeks, you would need to submit for a talk at the Global Summit, just to give an update and that the topic needs to stay the same, but you can change kind of what you're going to be talking about.
Okay. That is good to know. Do you know the exact date of the of when submissions close?
When they close, yeah, let me just take a look here because we were just reviewing some of the documents.
We're doing kind of a fortnightly call, so if it ends in 2 weeks, then we can't leave any of that discussion until next week.
So actually, it's available until June 16th. So it opens up today, May 13th, and then closes June 16th. And it will
Okay.
not be, there will not be any extension. So just plan ahead. June 16th, then the speakers will be notified July 14th after we review everything. And there's a lot of submissions. So if you feel like there's an opportunity to maybe submit for more than one, talk around this in different areas, you are more than welcome to as well. Just do not copy and paste the same content into it. Just make sure that the talks are unique in nature.
Okay. Thanks for that heads up.
Yeah.
I was not aware of the submission-based deadline, so that's good to know.
Yeah, they're just gonna send this out today, so be on the lookout for it and just put it on your calendar to make sure.
Okay, thanks.
Okay. So I have one more question for this work stream, right? We have a weekly meeting, right? Because like I think every work stream have a different schedule when they have meetings. So
Yeah, so we've fortnightly call. Have you registered on the Google Groups?
I don't think so, because sometimes I die in actually there's nobody there. So but yeah.
Yeah.
And do they have a specific email list or?
Yes, so we have an email list. ocp-all.groups.io/g/OCP digital twin. I will paste it in the chat.
Got it.
I also requested access to the drive. I don't know who's in charge of it, if you guys wouldn't mind taking a look at that. Just so I can I don't have anything to add to the white paper, but I'd be happy to review it for just content and.
Okay, yeah. Yes, okay. All right, I will.
whoever was trying to join the group, so if you click on that group IO, at the bottom, right before it gives you the messages or the calendar, there is a join this group on that group IO. You just want to click that plus join this group to be a part of it. And then all the emails and everything.
I've authorized both of your access to the
Oh, okay.
to the shared drive now. I have not seen anything yet either, so we'll keep an eye out. Are there any more questions? Kind of coming to the end of the call.
Okay.
Thank you so much, guys.
No,
Yeah, thank you. Thank you.
Yeah, thank you.
Have a great
Everybody.
day.
You too.
Okay, thanks very much.
Bye.
Bye.